Hello. In this problem, we're told that water is flowing over a flat surface at a rate of 4 feet per second, and on this flat surface there is a slit that is acting as a sink, pulling water with a flow rate of 0.1 cubic feet per second per foot length of the slit. We're also told to assume that the fluid is incompressible and inviscid. We're asked to locate the stagnation point on the wall, here point A, and determine the equation for the stagnation streamline. And afterwards, how high above the surface, h, the fluid must be so it doesn't get sucked into the slit. So, first, to state some givens, our u is equal to 4 feet per second, and the strength of our sink, m, is given by 2 times that volumetric flow rate, q, which is 2 times 0.1 feet squared per second, and it's feet squared because it's cubic feet per foot. And so that goes and cancels one of those feet out, and we end up with 0.2 feet squared per second for our m value. So to solve first for that stagnation point, what we're going to do is we're going to use the superposition principle to combine the stream function of the uniform flow and of the sink. To get that, once we do that, we're going to have a stream function for the flow overall, and we can find VR and V theta. So we'll start there. Psi is equal to psi uniform plus psi sink. And we know that the psi of a uniform flow is equal to UR sine theta, and that the psi of the sink is given by negative m theta over 2 pi. Oops, that's not a psi. That's a psi. Okay, so we have our streamline function. We're now going to go ahead and find VR and V theta and use the definition of a stagnation point to find out where that A is. So VR is given to us by 1 over R d psi d theta. So we're going to go ahead and do that. 1 over R d theta. All that good stuff from up there. We're going to go ahead and take the derivative of that. And that will give us a VR equal to U cosine theta minus M divided by 2 pi R. So there's our VR. Now, because we know this is sink and uniform flow, we know that our V theta is actually equal to 0. So we can go ahead and work with that and still use our definitions here to find some other stuff out. We'll go ahead and say the negative derivative of psi with respect to R is equal to V theta, which is equal to 0. So we have V theta is equal to negative d dr of psi UR sine theta plus negative m theta over 2 pi. And we end up getting V theta is equal to negative U sine theta, which is equal to 0. Now, in order for this equal to be 0, since we know that U is already assigned a value of 4, we have to assume then that, not even assume, we know that theta is equal to 0. That makes sense. We're talking about the stagnation point here. So, definition of stagnation point is that our velocities are equal to 0. Let's go ahead and take VR and set that equal to 0. That's equal to U cosine theta minus M over 2 pi R. So that R value is going to give us that distance from the sink of where A is. So solving this for R, and cosine of 0 is 1, so that's just going to go ahead and cancel out. We get R is equal to M divided by 2 pi U. So we have numbers for all those. You can just go ahead and plug and chug. That's 0.2 feet squared per second divided by 2 pi 4 feet per second, rather. And that will give us an R equal to 0.007 0.96 feet to the right of the sink, as you can see up there. Okay. So now we have that value for r. We're going to go ahead and find our equation for the streamline function at the stagnation point. So what we know at the stagnation point is that psi is equal to 0. So we can go ahead and set psi equal to 0 and go back and get this equation going again down here. 0 is equal to ur sine theta plus negative m theta over 2 pi. All right, so we can go ahead and rearrange this and say that r sine theta is going to be equal to m divided by 2 pi u, and all of that is going to be times theta. So we have values for all of these, and we can also go ahead and make this change over to polar coordinates. We can change that r sine theta to y. We can say y is equal to this number here, which is the same calculation that we did up here, 0.00796. Right, let me just make sure. M divided by 2 pi u and divided by 2 pi u, yep. All right, 0.00796 theta. So there is our streamline function for the stagnation point. So now we want to go ahead and find out what that h value is, because anything above that stagnation point is going to be free of this sink and we'll be able to continue on through this pipe, or over this flat surface rather. So we'll go ahead and make the change, y for h, and that's equal to 0.00796. And since we're now talking about the streamline equation for the stagnation point, we can go ahead and say that theta is equal to pi. And that will give us an h value of 0.025 feet. So anything above 0.025 feet, where this h is going to be able to escape the flow of the sink here. It's going to end up keep on going over this flat surface. Thank you and have a good evening.